Week 11 ATM MPLS InServe DiffServe. In the first section, we will talk about ATM. ATM is the short term of asynchronous transfer mode. It is a telecommunications concept for carriage of a complete range of user traffic, including voice, data, and video signals. ATM was developed to meet the needs of the broadband integrated services digital network, and the content will be divided into 5 parts. The first part is short fixed size packets, also called cells. Short fixed size packets carry information through the net, sometimes called fast packet switching. One of its merits is minimizing serialization delays for sensitive traffic. The fixed size should not be too small or too big, as the picture shows. When there are applications with larger data units, segment is at sender and resymbol is at receiver. If the size is too small, there will be too much overhead per byte of payload. If the size is too big, there will be source wasting or even cost the delay. In terms of deciding what fixed size, America proposed 64 bytes payload since it is a large country, while Europe proposed 32 bytes payload since they are all small countries. There is no echo canceller. The final proposal is 53 bytes, including 5 bytes header and 48 bytes payload. The second part is where ATM aimed to fit in. The choice is between network or link layer. Here is a picture showing where ATM network fit in reality. ATM a switch link layer connecting IP routers. The third part is ATM cell structure. An ATM cell always consists of a 5-byte header followed by a 48-byte payload. The header is composed of 6 elements, detailed in this figure. All elements include generic flow control, virtual path identifier, virtual channel identifier, payload type indicator, self-loss priority, and header error check. The fourth part is ATM adaptation layers. Originally, there were 4 ATM adaptation layers. First is connection orient constant byte rate, CBR. Second is covariable byte rate, UBR, VBR. Third is co-VBR merged with AAL4. 3/4 is connectionless VBR. The fifth part is switching virtual paths and channels. The figure here shows the physical mode of channels within a path within the transmission medium. In terms of virtual paths, the bandwidth of the transmission path is logically divided into separate virtual paths and identified using the VPI in the ATM header. Each virtual path is allocated a fixed amount of bandwidth. Virtual paths do not dynamically vary their bandwidth beyond what was being allocated. In terms of virtual channel, the bandwidth of a virtual path is logically divided into separate virtual channels using a virtual channel identifier in the ATM header. Unlike virtual paths, virtual channels share the bandwidth within a virtual path dynamically. In the second section, we will talk about MPLS, which is the short term of multi-protocol level switching. The detailed content is as following. Multi-protocol level switching is a type of data carrying technique for high-performance telecommunications networks. It is initiated by desire to send IP over ATM. However, comparing with ATM, MPLS packets may have variable lengths, and routing can be done using established IP protocols. In this page, some of the MPLS terminology is introduced. Packets have multiple levels, each indicating how it should be switched in different domains. Levels can pushed onto the stack at source and be popped off the stack by egress routers. Multi-protocol lambda switching is a combination of control plane and of MPLS with the point and click provisioning capabilities of photonic switches. It will enable equipment in the service layer to dynamically request bandwidth services from the transport layer using existing control plane techniques. In terms of setting up label switched paths, two aspects cost it, which is data-driven and control-driven. In addition, LSP is determined by layer 3 hop-by-hop routing and on explicit route specified by the source.